So let us see some software testing basics, questions and answers generally asked in interviews and vivas. So let us start with this. Can you explain the PDA cycle and where this fits in? You have to tell about PDCA cycle and fitness in testing. So software testing is an important part of software development process, as we all know. And in normal software development, there are 4 important steps, also known in short as PDCA: plan, do, check and act. Plan, do, check and act. This is a cycle. So plan, do, check and act. Again, plan, do, check and act. Then these steps are: plan means define the goal and plan for achieving that goal. Do or execute means depending upon the plan strategy we have decided during the plan stage, we do execution according to this phase. And then check means check or test, ensure that we are moving according to the plan or in getting the desired result. And act means during the check cycle, if any issues are there, then we take appropriate action according to and revise our plan again. So developers and other stakeholders of the project do this planning and building, while tester do the check part of the cycle. The first software testing is done in check part of the PDCA cycle. Now the other question may be, what is the difference between white box, black box and grey box testing? Black box testing is testing strategy based solely on the requirements and specification. And black box testing requires no knowledge of internal paths, structures and implementation of the software being tested. And white box, on the other hand, testing is a testing strategy which is based on internal path, means code structures, implementation of the software. This is being tested. And white box testing generally requires detailed programming skill. There is one more type of testing called the grey box testing. We look into the box being tested just long enough to understand how it has been implemented, right? Grey box, we just look into the box being tested just long enough to understand how it has been implemented. Then we close up the box and use our knowledge to choose more effective black box testing. That is how grey box is testing. Means you do a little bit of white box testing and then you do the black box testing. So this tester, then he does it. Say there is an application called accounting application. He does black box testing. The results are like this. And white box testing, the test database is with him. He tests with this web forms, tests the source code, and the result are there. And these figures show how both types of testers view an accounting application. Just for example's sake, we have taken this during testing. So black box testers view the basic accounting application. White box, during the white box testing, the tester knows the internal structure of the application. And in most scenarios, white box testing is done by the developers as they know the internals of the applications. So in black box testing, we check the overall functionality of the application, while in white box testing, we do code reviews, view the architecture, remove bad code practices, and do component level analysis or component level testing. Now you may be asked, can you explain usability testing? This is generally asked question. So usability testing is testing methodology where the end customer is asked to use the software to see if the product is easy to use and to see the customer perception and task time. Means user friendliness is being checked. So the best way to finalize the customer's point of view for usability is by using prototype or mock-up software during the initial stages. So by giving the customer the prototype before the development even start, we confirm that we are not missing anything from the user point of view. So usability means prototype or mock-up test. What are the categories of the defects? Defects are very important as far as testing is concerned. So you may be asked, what are the categories of defects? So there are 3 main categories of defects: wrong, missing or extra. Those things which are extra may also be termed as defects. So wrong means the requirement have been implemented incorrectly. The defect is a variance of the defect is actually the variance from the given specification or requirement. And missing means there are a requirement given by the customer and it was not done at all. So there is a variance from the specification, an indication that a specification was not implemented or a requirement of the customer was not noted properly. Extra means a requirement incorporated into the product that was not given by the end customer. So this is always a variance from the specification, but may be an attribute desired by the user of the product. Means you give him a product, or if he has not asked for the report generation, if you give him report generation, it will be helpful for him only. So this is extra, but this is defect, but this can be considered. However, it is considered to be a defect because it is variating from the existing requirement. Now the other question may be, how do you define a testing policy? These are the important steps used for defining a testing policy in general. So a testing policy is, it depends on the organization also. So let's discuss the detail of steps of implementing a testing policy in an organization. First, we define how to test, what to test. Then the definition, along with this we do the how to achieve part. Then we evaluate and we see the standards being followed. The definition, the first step any organization needs to do is to define any unique definition for testing within the organization so that everyone is of the same mindset. And how to achieve means, how are we going to achieve our objective? Is there going to be a testing committee? Will there be a compulsory test plans which needs to be executed, etc.? And then we evaluate, means after testing is implemented in a project, how do we evaluate it? Are we going to derive metrics of defects per phase, per programmer, etc.? Finally, it's important to let everyone know how testing has added value to the project. So for that standards, finally, what are the standards we want to achieve for testing? For example, we can say that more than 20 defects per KLOC will be considered below standard and code reviews should be done for it. So on what basis is the acceptance plans prepared, right? Acceptance plan are very important as far as testing is concerned. So the question may be, on what basis is the acceptance plans prepared? So in any project, the acceptance document is normally prepared using the following inputs, which I am going to tell you. This can again vary from company to company and project to project. So requirement document means this document specify what exactly is needed in the project from the customer perspective, and input from the customer. This can be discussion, formal talks or emails. So project plan, the project plan prepared by the project manager also serves as a good input to finalize your acceptance test, and this figure shows the most common inputs used to prepare acceptance plans. So requirement document, input from user, project plan, and these three combined together can be a acceptance plan along with the user manual. So very important question is, what is configuration management? Configuration management is a detailed recording and updating of information for hardware and software components. Because whenever you are doing a project, there will be a hardware component, there will be a software component. So how you are going to record and update the information? So when we say components, we not only mean the source code. It can be tracking of changes for software documents such as requirement, design, test cases, etc. So when changes are done in ad hoc and in an uncontrolled manner, chaotic situation can arise and more defects are injected. So whenever changes are done, it should be done in a controlled fashion and with proper versioning. So at any moment of time, we should be able to revert back to the old version. And the main intention of configuration management is to track our changes if we have issues with the current system. So configuration management is done using these baselines, right? Baseline is important as far as configuration management is concerned. So how does a coverage tool work? How does a coverage tool work? So while doing testing on the actual product, the code coverage testing tool is run simultaneously. While the testing is going on, this code coverage tool monitors the executed statements of the source code, and when the final testing is completed, we get a complete report of the pending statements and also get the coverage percentage. So we get which statement was not covered, which was covered. Like you have actual source code, so software testing going on, we use the coverage tools also in conjunction with this. Now the other question will be, what is the best testing model? So in real project, tailored models are prone to be biased because they share features from the waterfall, iterative, evolutionary model, etc., and can fit into real life, time projects. So tailored models are more productive and beneficial for many organizations. So if it's pure testing project, then V model is the best. What is the difference between a defect and a failure? Important thing. When a defect reaches to the end customer, it is called a failure. So and then the defect is detected internally and resolved. It's called a defect. So failure is what is being the error which has been given to the end customer, and the defect is what we defect or error is what we resolve and first found and then resolved in our own testing or our own system, which was not being delivered as of now. The defect is, if it has gone to the customer, it will be a failure. If it is not, then it is called defect only. So should testing be done only after the build and execution phases are concerned? These concerned phases are being complete. So this is a very important question because there is often confusion that when testing is actually being performed. So in traditional testing methodology, testing is always done after the build and execution phases. So, but what's wrong? That's a wrong way of thinking because earlier we could catch a defect, the more cost effective it is. For instance, fixing a defect in maintenance is 10 times more costly than fixing it during execution. So in the requirement phase, we can verify if the requirements are met according to the customer need, right? And during design, we can check whether the design document covers all the requirements. At this stage, we can also generate rough functional data. We can also review the design document from the architecture and correctness perspective. So in the build and execution phase, we can execute unit test cases and generate structural and functional data in this execution phase only. So and finally comes the testing phase done in a traditional way, that is run the system test cases and see if the system works according to the requirements. During installation, we need to see if the system is compatible with the software. Finally, during the maintenance phase, when any fixes are made, we can retest the fixes and follow the regression testing. Therefore, testing should occur in conjunction with each phase of the software development, each phase. So are there any defects in the design phases or in the coding phase? Again, the same question in a different flavor. So the design phase is more error prone than the execution phase because design is actually the basement for the coding. So one of the most frequent defects which occur during design is the product does not cover the complete requirement of the customer. Second is wrong or bad architecture and technical decisions make the next phase execution more prone to defect. If the design is not clear or not worth, the code is definitely going to be not good. So because the design phase drives execution phase, it's the most critical phase to test. The testing of the design phase can be done by good review. On average, 60% of the defect occur during design and 40% during the execution phase. So 60% error during design and 40% error during code. So what group of teams can do software testing? This is a very important question. When it comes to testing, everyone in the world can involve, right from the developer to the project manager to the customer. So below are different type of team groups which can be present in a project, like isolated testing, outsourcing. We can hire external testing resources and do the testing for our project. Inside testing, we can have developers as testers and quality assurance and quality control teams. The other question may be, what impact ratings have you used in your projects? This is very important. Normally the impact ratings for defects are classified into three types, means minor, major and critical. This minor, major, critical. Minor is very low impact but does not affect operations on a large scale. Major means affect operations on a large scale. Critical means it will bring the system to a halt and stop the show. Then you may be asked, does an increase in testing always improve the project? Okay, does an increase in testing always improve the project? No, an increase in testing does not always mean improvement of the product, company or project. In real test scenario, only 20% of the test plan are critical from a business angle. Only 20%. So running these critical test plan will assure that the testing is properly done. So which paragraph which is coming or graph which is coming, the impact of under testing and over testing are being shown. So if you under test a system, the number of defects will increase. But if you over test a system, your cost of testing will increase. Even if your defects come down, your cost of testing has gone up. Okay, I'll show this thing again sometime because there is a part 2 also. But let us come to this question 16. What's the relationship between environmental reality and test phases? Environmental reality becomes more important as test cases start moving ahead. Okay. For instance, during unit testing, you need the environment to be partially real. But at the acceptance phase, you should have a 100% real environment. That means you can say it should be the actual real environment. Also, every phase, the environment reality should also increase, and finally, during acceptance, it should be 100% real. This is like this. This is the graph. This is the test phase. This is the environment reality. So unit phase, okay, 10% is okay, but as the time of acceptance, it has to be over 40%. Now you may be asked, what are the different types of verifications? Verification and validation. There are two different important words in your software engineering. Verification is done against the design document or design phase, and this validation is done with respect to the software requirement specification or requirement phase. In verification, we see, are we building the product right, and validation says, are we building the right product, because it is what we have intended. So verification is a static type of software testing. It means code is not executed, the product is evaluated by going through the code. Right, static type software testing verification is there. So type of verifications are walkthrough, means walkthroughs are informal, initiated by the author of the software product to a colleague for assisting in locating defect or suggesting for improvements. They are usually unplanned, and authors explain the product. Colleagues come out with observation, and author notes down the relevant points and takes the corrective actions. Inspection is there. So inspection is a thorough word-by-word checking of a software product with the intention of locating defects, confirming traceability of relevant requirements, etc. So how do we test, or how do test documents in a project span across the software development cycle as DLC? We'll show you how test documents span across the software development life cycle, and we'll also see the specific testing documents in the life cycle. So this is the project test plan. This is the central test plan. For that you have unit test and system test plan. You have integration testing plan, your acceptance testing plan. So this is the figure which show how test documents span across the software development life cycle. Also, it discusses the specific testing documents in the life cycle. So right from your unit to system to integration to project to acceptance and central test plan. So central project test plan is the main test plan which outlines the complete test strategy of the software project. So this document should be prepared before the start of the project and is used until the end of the software development life cycle. You make a central or project test plan. Then you make the acceptance test plan. Means the test plan is normally prepared with the end customer. This document commences during the requirement phase and is completed at final delivery. Then when we come to system test plan. Means the test plan starts during the design phase and proceed until the project. And the integration and the unit test plan means both of these tests start during the execution phase and continue until the final delivery. Now you may be asked which test cases are written first, white boxes or black boxes. So normally black box test cases are written first and white box test cases are written later. Because in order to write black box test cases, we need the requirement document and design and project plan. That is why black box cases are written first and white box are later. All these documents are easily available at the initial start of the project. So we have this strategy. So while white box test cases cannot be started in the initial phase of the project because they need more architecture clarity, which is not available at the start of the project. So normally the white box test cases are written after black box test cases are written. Black box test cases do not require system understanding, but white box test needs more structural understanding. And structural understanding is is clearer in the some later part of the project, that is while executing or designing. So for black box testing, you need to only analyze from the functional perspective, which is easily available from the simple requirement document. So design document, you have requirement document and plan. You all have this, and after design document, you can just go to the black box testing, and then white box tests can be done. So this was the first part, and we'll see the later coming questions shortly. Thank you so much. Take care of yourself.